Informally fitting a line, 8M6, lesson 8. Lesson 8, you can see it, yeah, right here. Right here. Whoops, right. It's kind of backwards. It's hard for me to do this with my finger. Informally fitting a line. All right, so we're going to talk today about, we're just going to extend what we've been learning so far about scatter plots and drawing lines and finding statistical relationships. So let's get going on that right now. So let's cut over here. And first of all, let's review what we have learned so far. So in sum, we've been talking about scatter plots. Scatter plots are where we compare relationships between two variables on a Cartesian plane. Otherwise, we usually call them graphs. So then once we compare those relationships, we put down all of our points, our data points. We look for a statistical relationship between the two variables by identifying whether the y value, does it increase or decrease as the x value increases. So on our chart, do our points kind of tend to go up? Maybe, or maybe they tend to go down. And we're looking for that kind of relationship. If the y value stays constant, so sometimes though, as we go from left to right, the value is flat. And if it stays relatively constant, then there's no statistical relationship. So over here we have no statistical relationship because as x gets bigger or smaller, y stays about the same. We don't really see y go up or down. Over here, however, if the y value increases or decreases, there is a statistical relationship. So here as x gets bigger, y gets bigger. So this is a positive relationship. And in this case, as x gets bigger, y gets smaller. So here we have a negative relationship. And the other thing we look for is whether it's linear or not. Like in this case, it's probably linear. In this case, it's probably linear. Sometimes we'll get some data that looks something like, maybe something like this, where there is a positive relationship, but it's not, it's more of a curve than a straight line. So this would be a positive statistical relationship, but not linear. So this is all review of lessons 5, 6, and 7. And now in lesson 8, we're going to add something new. This is our new learning for today. So today we're going to take our scatter plots one step further. You know, I didn't lay down any happy cat. Oh, a happy cow. Wait, we got to get back to happy cat. Happy cat. There we go. And the happy cat today is going to learn that if there is a linear relationship based on a best fit line, we're going to draw conclusions about it. And I think I'm going to, and I created this example here. And in this example, we have kids who are, kids are going to bounce. I don't know where my letters went. So we're going to bounce a ball into a cup 5 times. 5 times. And so I took some data. So these kids practice. Some kids didn't practice, 0 hours of practice. And some kids practiced a lot, 10 or 11 hours. Boy, they played this game a lot. And the way you play the game is you throw 5 balls in the cups. And if you get the red cup, you get 3 points. If you get the blue cup, you get 2 points. And if you get a white one, you get 1 point. So really the highest score you can get is if you hit the red cup 3 times. The best score is equal to 15 points. And then the worst score, you could actually miss them all and you could get 0 points. So you could get 0, a miss, altogether 0. So the worst score is 0. So you can't actually get a 0 in this game. So I recorded scores of kids that practiced a lot and a little. And so I took this data. So what do you kind of notice? you can just kind of look at the data and make some observations. I'll give you a chance just to, why don't you pause and look at this and see if you can draw a conclusion, just looking at the data. And then we're going to graph it. Okay. Okay, I think what you can see is that the less practice, you get lower scores. And more practice, you get higher scores. But let's graph it, and then our eyes will really see the answer. So let's see. So hours of practice, we're going to put that over here on the x-axis, and on the y-axis, we'll put score. Because x is the thing that you can change, and then your score is the thing that we're going to test against. Sorry about that noise. It's a printer going right now. But let's see. 0 hours of practice, we can get a 4, 0, 4, 0, 3, let's see, 2, 5, 1, 2, 3, 4, 5, 5 is here. 2, 7, 5, 10, 10, 12, 11, 15. Oh, this person got a perfect score. 9, 7. Whoops, this point should have been here. What am I doing? Uh-oh. Wait, that's 5. That's 0. 1, 2, 3, 4, 5. Uh-oh, this should go up 1. What am I doing? Let me just, shoot. Let me just make sure I got the exact right thing here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then this is 5, 6, 7, 8, 9. Okay, so now we're right. Sorry about that. Thanks for hanging with me on that one. And then we have 5, 10, 10, 12, 11, 15, 9, 7, and then 7, 9. I think I got this data drawn right here. 9, 12. No. So this one shouldn't be here at all. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's all our points. So now we can start to draw. Now what would you now the next step is to identify whether we think we have a positive statistical relationship. And I think the answer is yes, that we do. We can see that as we go from left to right, and it's really easy to see visually that we have a positive. The lower scores are here, and the higher scores are off to the right. So let's do our trick here where we kind of outline our points. And now we can draw a line that best fits those points. So let's try one that goes from here to here. And let's see if we can verify that that looks like a best fit line. And I want to show you a kind of a trick to this. Let's see if we can make that line like a different color. Yeah, so we're going to make it like light blue. So let's look here at our line, and let's look at our points. And on our points, we'll notice that we have a point that's above the line, another one above the line, another one above the line, another one above the line. We have 3 points below the line, and then we have 2 points that are right on the line. So we have 4 above, we have kind of 3 below, and then we have 2 on the line. So that's a good fit because you want a good balance above and below the line, 4 and 3. So I think that this blue line here is a pretty good fit for the data. So let's just go ahead and select this blue line one more time, and let's make it like a dark purple so we can really hone in on it. Because now what we want to do, now that we have a best fit line, we can start to make predictions. So we can kind of forget about our points and start to make predictions off of this line. So let's see how that's done. So this is the new thing that we're learning today. We've kind of learned how to make how to identify a linear relationship, how to we've drawn a few best fit lines, but now we're going to really make some predictions. So what score would you predict for a student that practices for 4 hours? Well, let's see. 4 hours is right here. So let's make a little dashed line at 4. So this would be 4. And we would predict that a 4 hours is about a score of a 7. 4 hours would be about 7 points, we think, given our model. Now we can answer questions in the other direction. If I want to get a score of a 10, how many hours do you think I should practice? So now instead of coming down here on the hours practice, we're going to look at our score of 10 and then dash over here to the right and then dash down. And we'd say, we think the answer is 7 hours. 7. We ran out of room. Okay, you see how that works? So what we're going to do on the next 2 examples is we're going to do the exact same thing, and we're going to test our model, test our data, see if there's statistical relationship. If there is, we'll look and see if it's linear. Then we'll make a line, and then we're going to answer some questions. And this is fun. This is fun math. This is the kind of math that you can do. You can do if you read data online. You see it in a newspaper. You hear it on the radio. You can make your data points, and you can answer your questions for yourself. You don't have to take other people's words for it. So this example came out of the book. And then the next example I found online, so it's going to be a little bit new. So this is one that you did in class today. And so the question is does water go faster or slower when the water is shallow? In this river, the Columbia River in Washington State, they did some measurements. And they figured out if it's shallow water, so this is shallow, 0.7, up to deep. This is deep water. 11 feet deep. That's higher than my head. I'm about 6 feet tall, a little over 6 feet. And this would be shallow. This would be like just over your ankles, 0.7, less than a foot deep. So the water over here is faster. This is fast, 1.55 feet per second, and down here it's 0.22. So that's slower. So what will you notice? What can you tell about the relationship between the depth and velocity by looking at the numbers in the table? I encourage you to pause after every time I ask a question and make sure that you, or to make a guess or to make a qualified guess as to what you think the answer is. Well, it looks like deeper is slower and shallower is faster, right? If it's shallow, we have fast water. If it's deeper, we have slower water. That's what the data looks like. So if we were to make a scatter plot of the data, which variable would you put on the horizontal axis and why? And usually the horizontal axis, this is a question of which one's easier to measure. It's kind of like the X is what they call the independent variable. And this is the one that we usually measure. And then the Y is the one that we then guess at or then observe. Okay, so typically, what do you think you're going to measure and then measure first? And then what do you think you're going to observe or guess at and then measure second? probably, in this case, probably the depth is going to be the x. That's probably what we measure first. You can also thinking of it as the easiest to measure. Okay. So now let's actually make the plot of the data. The plot of the data is given in the book. So watch what I do here. Boom. There we go. Let's get rid of these markings now. Whoops. Just a second. Bear with me while I get rid of these markings. And there's our scatter plot. Okay. So now we can see visually that as the depth increases, that the water gets slower, right? Fast water for shallow water, and then slow velocity for deep water. So now what we want to do is we want to choose a data point in the scatter plot and describe what it means in terms of the context. So go ahead and do that. I'm going to choose this one to talk about. Well, no, you know what? I'm going to choose this one and then this one. And you can think about what they mean in terms of the context of this story. Okay. Well, hopefully it's pretty straightforward. The answer is here we have a very shallow, we have, less like 0.7 feet. And the water is traveling at 1.5, 5 feet per second. So shallow and fast. You know what? I'll put it over here. 0.7 feet, and the water is 1.55 feet per second. So that's shallow and fast. And I know it only said 1, but I'm going to do 2. So here we have about 10 feet deep, and it's about 0.5 feet per second, 3 times slower. So it's deep and slow. Okay, so based on the scatter plot, I'm going to get rid of these things so we can actually, whoops. I'm going to do it like this again. Based on the scatter plot, what can we say now about the relationship between velocity and depth? We can say, well, it's a negative, and I think we can say that it's linear. This is our guess. Again, it's not proving, but it's a negative linear relationship. So let's go ahead and, we'll make the line here when they tell us to make the line. How would you explain the relationship between velocity and depth of water? Well, we just kind of answered that. It's a negative relationship. If the river is 2 feet deep at a certain spot, how fast do you think the current would be? Explain your reasoning. Well, let's look at it. 2 feet deep. Well, do we think that every spot in the river would have, if it's 2 feet deep, it would be 1.1? Or do we think probably that a line goes more like this, and that 2 feet deep, it may be a little faster some of the time and slower some of the time? That's going to be kind of the question. I think the answer is, I think this is not a good estimate given the other points, because we think the line is going to be a little bit higher. So I think that this is kind of like a trick question. I think it's going to be faster than 1.1 feet per second. I think it's, which this point is at 1.1. I think it's going to be probably more like 1.3. Okay, So now let's draw a line to represent the trend in the plot. So I want you to try to do this in your book. And I think what you want to make sure you do is make sure there's the same number of points above and below the line. So I'm going to do that. And I'm going to try and, I think, let's see here. No, I don't think that's a great guess either. I think it's going to be more like this. Let's do that. Okay, and the reason I go with this, why am I going with this? Because in this case, I have 1, 2, 3, 4 above the line. I have 1, 2, 3, 4, 5 below the line, and then I have 2 on the line. So I have 4 above, I have 5 below, and I have 2 on the line. So that's a pretty good balance. That's a pretty good balance. So let's go to orange. And now let's see, if you draw a line to represent, will it make it easier? So the answer is yes. Yes. Visually, we can answer quickly. So check this out. Draw a line that you think does a reasonable job of modeling the trend line. So we just did that. And predict when the water is 8 feet deep where it's going to be. Well, geez, we could do that so fast. If it's 8 feet deep, boom. Boom. We predict that it's going to be 0.75 feet per second. Use the line to predict a velocity for a depth of 8.6 feet. So let's do 8.6, and that's right here, 8.6. And then we predict it would be here. That's 0.7. I'd say that's 0.72 feet per second. And now what they want to do is how far was your prediction off from the actual observed velocity for that specific location that had a depth of 8.6 feet. Well, I already deleted that data, so I'm going to have to go back over to my and look in my data. And so at 8.6 feet, it was 0. You know what? Yeah, that was the actual was 0.59. So it was 0.59 feet per second. So it was off by 0.13 feet per second. Not too far off. Not perfect. So the point here is that models aren't exactly perfect, but at the same time, if we went and we measured it in a different spot in the river that was 8.6 feet deep, it may actually be a little bit more. And I think it probably would be a little bit more. But again, this is a model, and the model is never going to be exactly perfect, but it's going to be pretty good for making guesses. We're not too far off. Okay, let's go to one last example, and this is going to be your final example of homework help. Okay, so I got this off the web. Here is where I'll give credit to where I found it. Found it online. This URL, just this data graph, and what it does is it graphs the height versus the weight of students in 8th grade. I'm going to say it's in 8th grade. I'm not sure it was in 8th grade, but this could be 8th graders, or maybe a little bit. Yeah, because 60 feet. This is 60 inches is 5 feet, and 72 inches is 6 feet. So students are, some students are 5 feet, some are a little bit less than 5 feet. You may have one 6-foot tall student, really tall student in 8th grade, maybe. And so this data would be pretty reasonable for that. So does there appear to be a statistical relationship between weight and height? I want you to pause and try all of these. Pause plus try these, all 4 questions. And you should be able to do that given everything we've learned so far. Okay. So does there appear to be a statistical relationship? And the answer is yes. Does it appear linear? And I think the answer is, again, yes. So let's make a line. And let's try and put half above and half below. And on is okay. So this looks like a pretty good fit. We have above, we have 1, 2, 3, 4, 5. Below we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Nope. So this is not really a good fit. We got to go a little bit lower. We got to go a little bit lower with our line. So let's see. Let's grab that line and let's go a little bit lower with the line. Like that. 1, 2, 3, 4, 5, 6, 7, 8 above. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this looks like a better fit for the line. Okay. Now let's answer some questions. Let's do it in blue. Okay. So how much do you predict a student who is 70 inches tall to weigh? So let's see, if we take 70 inches, I'm going to use a line tool here and go straight across. So if we're 70 inches, we expect to weigh about 100 and maybe 47 pounds. So we'd say 147 pounds. And if you're 100 pounds, how tall do you expect a student to be? Well, this is just kind of the inverse question. We start with the weight, and then we go up, and then we go straight to the left. And so we expect someone who is 100 pounds to be about maybe 5 feet. Well, let's just say 62 inches, which is 5 feet, 2 inches tall. So hopefully that was pretty straightforward. Let's put some happy cats down. Whoa, big happy cat. Down for graphing and answering these questions. And we'll just call that a wrap. So tomorrow we're going to be doing lesson 9, and we're going to maybe be trying to write equations for some of these lines. And that's going to be a little bit more powerful, where we can actually write an algebraic equation or estimating an algebraic equation. So hopefully this was a useful lesson, taking scatter plots to the next level, working a few examples, understanding, just again, continuing to understand how important it is to be able to model data on scatter plots and make predictions using those scatter plots. Because in this world, what's going to happen to you as you get older is people are going to begin to use data, and they're going to refer to data, and they're going to try and argue things to you using data. And data speaks volumes. But sometimes when they're using that data, they misuse it. And so it's very important that you yourself can understand how to model and predict using data, so you can either support or reject claims made by people trying to convince you of things using science, data, mathematics. You need to have the power. When you have the power, you have knowledge, you have power, you can make your own decisions, you have self-efficacy and all that good stuff. So we are getting along. Next time, yes, 8 and 6 lesson 9, getting towards the end of year 8 and graduation towards 9th grade. Well done.